and welcome to this session on chipping of sheet metal or shearing. Let us begin with the session.
Let us look at the objectives of this session. At the end of this session, you will be able to flatten a sheet using wooden mallet, mark different types of geometrical shapes, chip the different geometrical shapes by flat chisel. The tools required for this exercise are steel rule, divider, different grades and sizes of files, surface table, dot punch and center punch, ball peen hammer, anvil, scriber, a snip, tin man's anvil, wooden mallet, flat chisel. Cut the sheet metal to a dimension of 160 mm by 160 mm using a snip. Flatten the sheet metal on tin man's anvil using wooden mallet. Let us first learn about marking of square on sheet metal. Mark a square of 150 mm on the sheet metal using steel rule and scriber. Cut the sheet metal to get a square of 150 mm using a snip. Deburr the sides of the sheet metal using a file. Mark center lines perpendicular to the edges of the square to determine the center O using steel rule and scriber as per the drawing. Witness mark the arc center O using a prick punch and a ball peen hammer. Let us now learn about marking a circle on sheet metal. Set the divider to 60 mm length using a steel rule and mark a circle of radius 60 mm using the center O as per the drawing. Let us now learn about marking a hexagon on sheet metal. The radius of the circumcircle of a hexagon of known side A is equal to the side of the hexagon, that is A. To mark a hexagon of side 50 mm, initially mark a circle of radius 50 mm using a divider and steel rule. Set the divider to a length of 50 mm using a steel rule. Cut the circle from points P and S at point Q, R, T, U. Join the points P, Q, R, S, T and U to mark a hexagon of side 50 mm using a steel rule and scriber. Let us now learn about marking of a pentagon on sheet metal. For this, first, let us determine the radius of the circumcircle of a regular pentagon. The internal angle between the two diagonals of a polygon is given by theta equals 360 divided by n, where n is the number of sides. For a pentagon, the number of sides is phi. So the internal angle between the two diagonals is given by theta equals 360 by n, which equals 360 by phi, which equals 72 degrees. Consider one of the triangles so formed with angles subtended as 72 degrees and base as side of the pentagon. A line drawn from the apex to the base divides the triangle into two right-angled triangles as shown in the figure. We know that in a right-angled triangle, Sine of angle is given by the ratio of the opposite side by hypotenuse. Sine theta equals opposite side divided by hypotenuse. Sine theta by 2 equals a by 2 divided by r. So the radius of the circumcircle of the pentagon of side 40 mm is given by r equals a divided by 2 multiplied by sine theta by 2. R equals 40 by 2 into sine 72 by 2. Therefore, R is equal to 34.026 mm, approximately 34 mm. Set the divider to a length of 34 mm using a steel rule. Mark a circle of radius 34 mm using divider with the center O. Set the divider to a length of 40 mm using a steel rule. Cut the circle from point T at Z, Y, X and V to get a pentagon of X, Y, Z, T, V. Join the points T, Z, Y, X and V to mark a pentagon of side 40 mm using a steel rule and scriber. Now let us learn about marking of triangle on sheet metal. For this, first let us determine the radius of the circumcircle of an equilateral triangle. For a triangle, the number of sides is 3. So the internal angle between the two diagonals is given by theta equals 360 by n, which equals 360 by 3, which equals 120 degrees. Consider one of the triangles so formed with angles subtended as 120 degrees and base as the side of the triangle. A line drawn from the apex to the base divides the triangle into two right-angled triangles as shown in the figure. We know that in a right-angled triangle, sine of the angle is given by the ratio of opposite side by hypotenuse. Sine theta equals opposite side divided by hypotenuse. Sine theta by 2 equals a by 2 divided by r. So the radius of the circumcircle of the triangle 30 mm is given by r equals a divided by 2 into sine theta by 2. R equals 30 divided by 2 into sine 120 by 2. Therefore, R equals 17.321 mm, roughly 17.3 mm. Set the divider to the length of 17.5 mm using a steel rule. Mark a circle of radius 17.5 mm using divider with the center O. Set the divider to a length of 30 mm using a steel rule. Cut the circle at point L, M and N to get an equilateral triangle of side 30 mm. Join the points L, M and N to mark an equilateral triangle of side 30 mm using a steel rule and scriber. Let us now learn about chipping or shearing of sheet metal. Place the sheet metal on a metal plate and clamp it. Cut the triangle of side 30 mm from the pentagon-shaped sheet using flat chisel and ball-peen hammer. Cut the pentagon of side 40 mm from the hexagon-shaped sheet using flat chisel and ball-peen hammer. Cut the hexagon of side 50 mm from the circle-shaped sheet using flat chisel and ball-peen hammer. Cut the circle of 120 mm using small flat chisel and ball-peen hammer. Check the dimensions of all the geometric profiles using steel rule. To recap, we have learned to flatten a sheet using wooden mallet, mark different types of geometrical shapes, chip the different geometrical shapes by flat chisel.
So that's all about chip sheet metal shearing. Hope you have understood all the concepts and exercises. See you in the next session.